like 6 to 7 or 5 to 6,
No,
depending on.
not in the evening, in the daytime.
In daytime, it will be not possible. And Thursday and Friday again, that will be in evening, 6 to 7 or 6 to 8. And
Evening, forget about evening because
yes,
uh, the problem remains the same because throughout the day I have so many classes. Then after attending all these classes, I doubt whether things will be running very smoothly with this digital limitation and all this.
yes, sir.
That I am
And
trying to convince you. But
yes, sir,
when
yes,
if the things in future, if something else happens, then we may accommodate accordingly as per your availability, or we may consult, we may
yes,
discuss.
yes, yes,
I also don't prefer Saturday, right?
yes, yes,
But
I
I
can
can't
understand.
help. This time I have a class during that time, and unfortunately, Friday at the same time there is another class with PG postgraduate, and that class had already been commenced in the past several weeks. So I can't suddenly I can't change or stop that class. And
Yes, sir.
almost they are on the verge of completion of their semester. So we may wait for so many. So where is Robin Bala? Who is Robin Bala? Joined right now.
Yes, sir.
So where from you are joining? Where from?
I'm from Nodia.
Nodia, but you try to come in time. The class
Yes, yes, sir.
has already been started at 10.
O- Okay, sir. I will try from the next time.
So anyways, that is that is regarding the classes. So for the time being, classes will be going on during this Saturday 10 to 12. And um, uh, let me wait for some more, maybe February, mid February. For the time being, we may take class only on Friday, Saturday, because Friday at the same time there is another class, so it is not possible. Again in the evening, some other part-time classes are there. So that is the problem. So Monday, when is possible on Monday? 5 to
Uh,
6.
5 to 6 or 4 to 6.
4 to 6 is not possible. 5 to 6, again I will have to check. Okay, next Saturday I shall tell you. But today is 22nd.
Yes, 22nd.
So next class will be on 29th. Okay.
Okay.
That time, or you may do one thing.
So can I mail you that the stuff that what is available to us?
No, you may mail, but I have I understood your available time slot all in the evening or in the afternoon session. Mm. But in the morning, Monday morning is not possible.
No, sir, we have two classes, and that is also back to back from 10 to 12, then 12 to 1, 12 to 2.
Uh, so okay, for the time being, in the next week, today we are attending. So again, we shall meet in the next week. That time, within this time, I may think. So now this class, the topic, um, that is our subject is manufacturing process. So by this time, I think you have a workshop also. Whether that workshop had been started, manufacturing process, not
Sir,
manufacturing process, that is the
yes, yes.
workshop.
Sir, in previous two semester we had a workshop, and for this semester it hasn't been started yet for section B2.
No, you had workshops in those years. Okay, that's fine. Some topics are also included in this subject, but in the current session also, current semester, you have a workshop on
Yes, sir, we have.
workshop 3 most likely, that is forging
Yes,
molding.
yes, yes, yes.
So are you attending that workshop?
Ha ha ha. For section B2, it is
You
yet to be
have
started.
the three section.
Yes, sir.
So
Subsection,
three
yes.
section, in no section the class had been started. not in A1, A2, B1, B2, B3?
Sir, yesterday we had the first class in B3.
First class.
Yes, sir.
Acha, so what was the, I mean, workshop? There are two branches. So
Yes,
what?
sir. We were
Uh,
uh, we were we were being taught molding yesterday.
Molding.
Yes, sir.
Okay. So actually, in this workshop, you had workshop in the past year. So all these will be included. Uh, but current in the current session also, you have two workshops. Not two workshops. So workshop 3, but it includes two. I mean techniques. That is, one is molding or foundry workshop. It is, I mean, more general term, foundry, and one is forging. And these, all these are also will be discussed at length in this theoretical class. So, in this subject, manufacturing process, foundry actually dominates a major portion. Foundry itself includes so many other branches, so we shall discuss. Now, foundry and some other mechanical manufacturing processes. So, almost, it is not accurate, exact, but almost 60-40 may be the dominance of foundry to others. 60%, not 50-50, okay, majority is meant for foundry, where molding is one of them, right? Now, so it may so happen, not necessarily, sometime in the examination, we offer, say, 8 questions or 9 questions. Out of 8, 9, you may have to answer 5 or like that, flat mode. So out of 8, you answer 5 questions. So that is in a mixed mode, including foundry as well as some other manufacturing processes. The share of the foundry obviously is more, but sometime there may have two parts, part 1, part 2, or group of A, group B. Part 1 or group A may include foundry, the other part may include the rest of the manufacturing process. So again, say part A may include 4. So out of 4, you may have to answer 3. And in the other section, you may have to answer 3 or 2. Okay, so in this way, questions are given. So that's why you should prepare all the things. Don't concentrate on a particular area. And there are some mathematical portions followed by the theoretical. Majority of them are theoretical. And one important point in this subject actually is the drawing. All the answers must be supported by some sketches, figures, level drawing using pencil, not by pen. So time and again I am uh, mentioning this. Don't use pen, but still then you are using pen. So because the drawings are very basic basis of this subject. So good drawing is required. And drawings, if the answers are supported by drawing, then more marks may be scored, right? Without drawing or without good drawing, obviously marks may be reduced. So that is the modality of the subject. Now, with this brief introduction, I would like to start the subject. Just I am
So will the drawings we need to be done in pencil? Because in the scanning,
pencil drawing.
okay, sir. But during scanning of those images, the pencil markings become very faint. But those
Huh.
lines won't become prominent.
For that, you may use sketch pen also, but not ordinary pen. That is not good. You may use sketch pen. That's all fine.
Okay, okay.
Okay, so I'm sharing. Now, is it visible? Is the screen visible?
Yes, sir.
Sand casting. Okay, but before discussing sand casting, you tell me what is actually the manufacturing or concept of manufacturing or production. Are you aware of what is manufacturing or production? Now, this is because subject is manufacturing process, right? Name of the subject is manufacturing process. So what is manufacturing? Means that having some input, right? Having some input. And what are the inputs that I shall tell you? Having some input, you get some output. How you are getting output? Through some conversion process. Conversion process. So in this compartment, this is a black box model. Okay. This is a black box model where some input are given and some output are received. What is happening inside this black box, we don't know. But as engineers or manufacturing engineers, so this is the black box may be anything in electrical aspects. This black box may be some electrical processes, instruments, etc. In magic, something else are there in the black box. But for us, this is the conversion process, or in general, the manufacturing processes. Okay. So this compartment is the various instruments, processes are followed, machines. Okay. So having some input, and what are the input? Input are nothing but, say, man. Man means the workforce, human being. Okay. Man, material. Material means the raw material. Then obviously we must have the finance, that is money, man, material, money. And not only this is sufficient, these are sufficient, we must have the proper technique or method, man, material, money, method, and machineries. Machineries. Not only this, we may have some other aim, that is, in the recent age, in the recent time, with the advent of computers, ITs, all these, information technology, the recent time, this aim is very important dimension. This stands for the message or information, message. So this is the model of manufacturing process. Having some resource and all these input, all these, maybe many more, many things. Okay. So all these are known as the resources, basic resources. Human resource, right?
Yes, sir.
So in this way, we may have various resources. So having man, machine, money, method, material, message, at least these basic minimum as input. So those inputs are entering into some black box, as if some magic is going on. And we are getting some output. Now, what are the outputs again? Maybe either tangible or intangible. Means we may receive some goods or products. Goods or product part. Or we may also receive some service which can't be felt, that is not tangible, but intangible. That is, we can feel, we can appraise, we may be satisfied aesthetically. Okay, so goods or services. So input is coming to some black box and we are receiving some goods or products or services. And in this black box, if we are layman, we don't bother what is going on. Right? Like magic, when we are observing magic in stage, magic show, the general people don't bother how that is happening, what is going on, but they are satisfied. Satisfaction is their expectation. But magician, they are bothered, okay? Because this is not a automatic process. So various things are going on inside the black box. Similarly, for manufacturing engineer or mechanical engineers, production engineers, this black box means the conversion process, how the input, all these resources are amalgamated, are utilized and managed to convert the basic raw material, that is material, one basic resource, conversion of raw material into valuable product or good, which will serve some intended function, requirement of human being. Like say iron ore. Iron ore is not looking good, is unnecessarily heavy, mixed with various impurities. So nobody is interested to carry, say, a lump of iron ore. Say, if I give you a lump of iron ore free of cost, obviously that will not be accepted, because that is unnecessarily heavy, dirty, very dirty, mixed with various muds, impurities, sand, soils, etc. And obviously that will block some area, that will not serve any purpose. That is not looking good. But as soon as through some conversion process, a very good knife or razor blade is produced, or a say utensil is produced, steel plate, or a say furniture is produced, wrought iron furniture, right? So that is highly costly, highly valuable. That will serve some purpose of human being. Not only that, some aesthetic satisfaction will also be there. So this is the concept of goods and value addition, conversion of raw material into value added product. So production or manufacturing is basically the concept of value addition. And there are various, as we are writing here in the compartment, this is manufacturing processes. Our subject is manufacturing processes. Basically, this is a value addition, conversion of basic raw material to valuable product or service or goods. What is the example of service or goods? When you can't receive you can't feel, you can't touch the product or the output, but you may feel, you may be satisfied, like say hospitality service, catering service, railway reservation, ticket reservation, hospital service, medical. You are not receiving a tangible thing, but you are satisfied, right?
Yes, sir.
That is also the same techniques are followed to provide you output, either goods or service. And manufacturing processes, so there are number of processes. because the task manufacturing processes means the value addition, conversion process from raw material to output, utilizing various machineries, methods, money, that is resources. Okay. In the next year, third year, we shall have a subject known as industrial management. So in that subject, the managerial aspect, that is the technique, how to manage. So that those things will be discussed. But here in the process, that is the technical. That is basically related with the application of machineries, methods. But the subject industrial management deals with various mathematical and statistical models to optimize the benefit. Optimization means maximization of profit, minimization of loss, maximization of, say, quality of a product, minimization of the idle time, waste, etc. So those are the techniques. Now in this subject, manufacturing process, obviously this is the technical aspect, that is the machineries, methods, all these used. And there is another very vast manufacturing techniques subject process, that is machine tool, application of machine tools. So that is again so vast, that is taken care of separately in a separate subject, maybe in the next year also, or maybe in the second semester. Machine tool technology, right? Now here, manufacturing process means the conversion. So we are familiar with some of them in our first year workshop. I don't know whether you had a full-fledged workshop or only just glimpses, 1 day, 2 day visit. I don't know. But you had the exposure with welding section, welding. No, this time all these are in virtual, that's fine. But what are the topics? Those had been covered. Welding and other shop, regarding other shop. Only welding or pattern,
In first semester we had
foundry, forging,
carpentry.
etc.
In first semester we had
Which one?
carpentry.
Which one?
So carpentry.
Carpentry. There were 5 jobs, is not it?
Yes, yes, yes. But we had only studied one because in this online mode.
You studied one, but do you know what are the, I mean, different joints, patterns, at least the names?
Yes, sir.
Yes,
First
sir.
semester B3 तक अपनी नहीं चलन.
Okay. So, what is the basis of all these? You had observed some videos, but this is the actually concept. Because in say for example, carpentry, what is the raw material? Wood was the raw material.
Yes, yes.
Yes.
And we had so many tools. Tools means, say, saw, then mortise chisel, farmer's chisel, then some your rasp, mallet, wheel brace, so and so forth. So those are the tools and accessories. Accessories means which are not directly used for metal removal, like say saw, hand saw. For woodworking, what is the name? Hand saw. And what is hacksaw? Do you know
Steel
what is
cutting.
hacksaw?
For steel
That has
cutting.
been used in metal cutting.
That is for metal cutting. Yeah. So similarly, rasp. Rasp is like a file, but not file. File is meant for metal polishing. Okay.
Yes,
For
sir.
smoothing the surface of the metal, rough surface, files are used of different sizes. But the same technique is the rasp. for woodworking, for polishing, right? We have also emery paper for smoothing the surfaces.
Yes,
So
sir.
those are the tools, and some other requirements are also there, like a steel rule is needed, and an outside caliper, inside caliper, those are needed. But those are not directly removing materials. So those are supporting the total operation. But without any steel rule, without any, say, tri-square is also not taking direct part in the metal removal, but it is an essential minimum. Without tri-square, without steel rule, uh, without, say, a pencil, you can't complete the job. So those are the essential minimum, but not taking part in direct metal removal. So those are known as accessories. So both tools as well as accessories. And machine used is known as machine tool, right? So these machines, tools, accessories, human being, that is the workforce, right? Along with so many other things, message, information. You had a job sheet, say job sheet may be considered as the message. Money obviously is required to procure the raw material, tools, accessories, all these. The wage of the people is money is essential minimum. So those are the inputs in that pattern making shop, and the process, manufacturing process follows the pattern making. I mean, theories, discussions, all these, and we are getting some output that is either a joint or a pattern or what else. In case of furniture, we may receive a wooden furniture also. All these are valuable products. So that is the concept of value addition. So in the pattern making, that is the value addition. In welding again, we have various pieces of metals, various smaller pieces of metals, and following a drawing, we may join those single pieces to give a desired shape. Joining, that is a fabrication or joining. So that is also a value addition. The fragmented pieces, when, say, the case of a grill, household grill, so various strips of iron metals are fragmented pieces are joined by welding, arc welding or gas welding or some welding method. There are various methods, right? So those will be discussed in detail in this welding techniques. Similarly, we have glimpses of pattern making tools, types of patterns. Because why important? Pattern is very essential part in foundry, right?
Yes, sir.
And then we had you were not exposed with, I think, foundry and forging shop, most likely. Fitter shop, okay, fitter shop is also there. So again, we shall discuss. I don't know whether you are familiar with fitter shop. So this is the concept of manufacture. I think by this time you understand, you are understanding what actually is our intention. That is a basic conversion. And
Yes, sir.
as per the accordingly, we have different processes. That is, when we are following woodworking, so that is known as pattern making or woodworking, carpentry. So that is a manufacturing process. When we are entering into welding section, that is welding process, right? Similarly, in this way, we have foundry as a manufacturing process. Forging is another manufacturing process. Fitter shop is another manufacturing process. And machine tool. Machine tool, I have mentioned, is a vast area. So that it will be dealt with separately. Okay. So, okay. So this is the, uh, I mean, what is to say is the summary of the subject. And as we have mentioned that foundry is the majority of the portion, so we shall start with foundry. And foundry, the task of foundry is to produce the material. Okay. Material means the job.
Yes, sir.
So how that is produced? We have various processes. Foundry means, again, to start with, I should say that I must have some molten metal. Now, how I can get metal melted? In furnace. Okay, in furnace. Metal melting furnace. There are various types of furnace. Baking furnace, but baking furnace will not be helpful. So we must have metal melting furnaces. So we shall learn about the various furnace, metal melting furnace, because melting the metal is very important. So after getting the molten metal, this metal will be poured into a cavity, a mold, which is known as a mold. This molten metal will be poured into a cavity. Cavity, also known as mold. Cavity confirming the geometry or shape of the object to be produced. Right?
Yes, sir.
And after, say, pouring the molten metal in this cavity, conforming the shape or geometry of the object to be produced, after it allow it to cool or solidify. So after solidification, take out the part. So that is known as cast part. Not casting, cast. After solidification, the resultant part is known as cast. And all this process, that is starting from the melting of metal, pouring into the preparation of this cavity. Preparation of this cavity is the purview of foundry. How the cavity is produced. Cavity, I am in a single term, I am mentioning the metal is poured into a cavity, but this is not as simple. How the cavity is prepared. So preparation, pouring the molten metal in the cavity, and after solidification, the resultant part is known as cast. All these processes are the casting process. This is not casting. That part is not casting. The process is casting. And all these processes, that is pouring, melting metal, preparation of the cavity, pouring the metal in the cavity, getting the cast, all these together is known as foundry shop. Okay.
Yes,
And
sir.
then I have mentioned, so we shall learn separately what are the different furnaces, how the metal melting is going on, so on. And say for the time being, I have molten metal and I am pouring the molten metal in a cavity. Okay. The question is, first question in the foundry, say preparation of the sand mold. this cavity, mold or cavity. The cavity, or also known as, again spelling, either mold is right spelling, again American, this is American system. You may also uh, write mould. So both are correct. In different books you will find different spelling. So how to prepare this mold? So I must have a pattern, what is known as a pattern. So you know how to prepare a pattern in the woodworking shop. Again, we shall discuss in detail about the pattern after some time, not to start with. So pattern, I must have a pattern. Pattern is, in brief, because we shall utter this term time and again during the discussion of foundry, molding, etc. That's why at least you should understand what is meant by this pattern. Pattern is, what is pattern? You know, you prepared one pattern, at least you had undergone through this video. So what is pattern? Any
Fixed
concept?
geometric shape.
Huh?
A fixed geometric shape.
Not geometric shape, but it is, obviously it must have a shape, but it is the
Replica of that.
replica of the object to be produced.
Yes, yes, yes.
Is not it?
Yes, sir.
প্রতিলিপি, যাকে বাংলায় বলা হয় প্রতিলিপি, ছাঁচ.
Yes, yes, yes.
Obviously that will have a geometrical shape, but it conforms the actual job. Okay. So when pattern is produced by some methods, by some materials, all these will be discussed in detail. Utilizing that pattern, we are somehow we are preparing a cavity. That is again very crude or superficial word. How to prepare that cavity? How to cavity? I am talking about cavity, but when pattern is inserted, that there is no cavity. So how to prepare this cavity utilizing this pattern? So that is the purview of this molding process. And molten metal is poured in this cavity. We are getting the part cast. So that is the casting process. Now when this cavity is prepared utilizing the pattern as well as sand as the raw material, molding material, not raw material, molding material, that is known as sand casting. But sand may not be the only molding material. We may have various other molding materials. So that will again be discussed. But in the workshop video, some of the one section had undergone yesterday or some day. Had you observed the technique? Who was telling that yesterday you had a workshop?
Sir, me.
So whether that video was demonstrated?
Yes, yes. The foundry that pattern making it was demonstrated.
Yeah. So what is the name? Can you remember? Name of that job?
Like name of the process that was like preparing the thing.
So sand was the ingredient, molding
Mm-hmm.
sand.
Mm-hmm. It
So
was
that is
being.
sand casting, right? And what
Yes,
is
yes,
the
yes.
name of the job? Can you remember? Or name of the pattern? Okay, you can't, because, but
No.
you must remember, because all these are integrated,
Okay.
right? When you have a workshop and parallelly you have a theoretical class, and not only that, in the last semester you had a workshop on pattern also. So the name of the job is reversing. All of you should note, because in the future also you will observe. So this is very important part. The name of the job that was produced in the foundry in the workshop video, that is known as reversing gear handle of a lathe. First job, reversing gear handle of a lathe. So this part actually is having a shape and prepared with wood, and when that is used to prepare a cavity utilizing sand as a molding material, that is the sand molding. Sand molding means preparation of the sand cavity, and when molten metal, say cast iron, will be poured in that cavity, after solidification we will get a cast part, and the part, that is reversing gear handle, as the name suggests, reversing gear handle of XYZ, not that. Reversing gear handle of a lathe. So lathe is the machine tool where this part will be utilized. So where lies the machine tool? In the workshop. In our workshop, there are a number of lathes, and obviously one of the major part of a lathe is reversing gear handle. How it works,
So,
where it is fitted, all these will be uh, discussed later on in due course of time.
so,
But you should remember the name. Bolo.
sir, are these terms like casting process and foundry and molding, are they equivalent terms?
Which one?
Casting process, foundry, and molding process, like you're saying, are they equivalent in terms of meaning?
Equivalent means total concept, as I have mentioned, that furnace, melting of the metal, pouring, and getting the cast part is the foundry, is a broader compartment. And sand molding is basically the preparation of the sand cavity. But and what is another term? Foundry.
Yes, yes.
Foundry I have mentioned. Foundry is the total concept. That is starting from the raw material to finished product, the total process. But crudely, sometimes we used to mean, say, by casting, we are meaning all the same. But actually, theoretically correct meaning is like this.
Okay, so.
So in
স্যান্ডটা দিয়ে আমরা প্যাটার্নটা তৈরি করছি, যার মধ্যে মোল্টেড মেটালটা দেবো, তারপর
pardon,
কাজটা বেরিয়ে
জোরে
যাবে।
জোরে বলো।
স্যার স্যার বলছি, স্যান্ডটা দিয়ে আমরা একটা ক্যাভিটি তৈরি করবো এবং তার মধ্যে মোল্টেড মেটালটা দিয়ে জাস্ট যেটা বেরিয়ে আসবে সেটাই আমার ফিনিশ প্রোডাক্ট, মানে সেটাই।
আফটার সলিডিফিকেশন।
আচ্ছা, আর যে বাইরের যে ছাঁচটা তৈরি করবো সেটা স্যান্ড দিয়েই মেন কাজটা করবো, তাই তো? ওটাই মোল্ডিং বলছি।
যদি স্যান্ড ইউজ করি, ইফ উই ইউজ স্যান্ড, then
আচ্ছা,
this is the sand casting. If
আচ্ছা।
other materials are used to prepare this cavity, then the name will be something different. So that will be
So,
discussed.
the purpose of pattern and cavity is not clear to me. I mean,
What?
how they are the purpose of pattern and cavity and how they're related.
Pattern and
Cavity or mold.
pattern is the replica. That is the masterpiece. Utilizing that pattern as a guide, we are preparing this cavity like a template. So that
Okay.
is the difference. Now you may ask, what is the difference between a pattern and a casting? That is a pertinent question. So that later on again that will be discussed. What is the difference, major difference between a pattern and a casting? A cast, pattern and cast.
স্যার ক্যাভিটিতে আমি যখন মেটালটা পোর করি, যেহেতু একটু টেম্পারেচার বেশি থাকে, তো ওটা একটু হতে পারে না স্প্রেড করে দিতে পারে, বা কি বলবো কন্ট্রাক্ট করে দিতে পারে, কিছু হতে পারে। তো
Obviously all these will be discussed. You just wait and watch.
Okay.
Because casting or foundry is a very vast area, as I have mentioned. In between, we may utter several terms which may not be understood for the time being. You will have to read and reread and all these. So that then and only then. So what you are telling is okay. Temperature fluctuation, solid contraction, all these again will be discussed. What are the remedies?
Okay, sir.
So this is the broad concept. Now sand, when sand is used as a molding material, then the name comes sand casting, but not necessarily sand is the only material. There are many more. So accordingly, there are various names. So we shall also discuss. So this is, though the figure is not good, don't worry. In various books, in all the books contains the guideline. So you shall learn. So this in a nutshell is the process, that is, this is sand, okay, and melting of metal in the furnace, as I have mentioned. Okay, furnaces are there to melt the metal, and this molten metal is now poured into the mold, that is cavity. So what I drew in the past year. And after solidification, it is going on. As soon as molten metal is poured, it is going on through solidification process, and we are taking out the cast part, not the cast, this cast part. We are taking out the cast. Now, not always, but sometimes this is a total picture, but not always. Sometime after taking out the part, after say product is taken out, and this part requires further treatment. Are you aware of heat treatment
Yes, sir. Yes, sir. We
in
had
the
material
material
science.
science?
Yes, sir.
So okay, fine. So why heat treatment is needed, you know then. So sometime to improve the properties, the grain structures, or say hardening, etc., all these, sometime the cast part may have to be heat treated. So it will enter into a heat treatment chamber. And after heat treatment, cleaning and finishing. That is the all these dirt and dust, protruded portions, all these will be removed, finished, that is finished. So sand particles, if it is a sand casting, then sand particles will be adhered on the periphery. So all these will have to be cleaned, and the dimension or shape must have to be finished properly. And if required, additional heat treatment may have to be accomplished also. And then inspection, check all the dimensions, details, utilizing measuring tools, and then find out the defects, identify the dimension. 1 minute, the battery is running down, so I am connecting it with charger. So inspection, and accordingly find out the defects, measure the dimension, and in case you may have to reject some part, etc. And then if heat treatment is not required, then you may just bypass this branch. So take the cast part, take out this route, and come to this cleaning, finishing, inspection, etc. So heat treatment, additional heat treatment may not be necessary all the time. Now here, observe the steps. So what are the sand casting steps? Preparation of the mold. Mold means the chach, replica, or cavity. Utilizing pattern, very important. Utilizing pattern, core, getting system, all these will be discussed. Don't bother for the timing. So utilizing the pattern, prepare a cavity or mold. And now at the same time, melt the metals in furnace, and then pour or force liquid or molten metal into the cavity. Then allow to solidify, and then remove. Heat treat if necessary, cleaning and finishing, inspection. So all these are the steps to get a cast part. Don't worry, that will be discussed later on. So what is going on here? Basic materials and equipment. Now, those who had already observed yesterday or in the last week, the sandblasting video, that's fine. Others, that is other two section also, you try to get the link of that video and immediately go through the demonstration. Because if you have some idea about how the things are going on, then it will be easier to understand, right?
Yes, sir.
Yes, sir.
Okay, sir.
So this is, say, a pattern, that is a replica or a copy, what is written a copy of the shape you want to produce. Maybe made of wood, plastic, metal. Again, we shall discuss separately what are the various materials of pattern. Say, for example, this is wooden pattern, wood. So you know how to prepare this type of pattern utilizing the basic hand tools of pattern shop. And now this is sand, not like this. Actually, sand is a mixed mass. It may have some very fine particles, very fine dust-like or powdery mass, and some coarser grains, very small to very large, and maybe of different shapes, not necessarily a circular or rectangular or square. It is a mixed mode, pentagon, triangle, okay, of various shapes and sizes. So that is a mixed mass. And not only this sand, what is sand? Sand is actually fragments of rocks. Rock, you know, rock mountain.
Yes,
So
sir.
how that
Yes.
is accomplished? Not in a single day or 2 days. Years after year, decades after decade, in the past several crores of years of transformation due to natural calamities. What are natural calamities? Volcanic explosion, eruptions, right? Volcanic eruptions, severe storms, thunderstorms, floods, earthquakes. What else? So after all these natural calamities, natural, not artificial, natural calamities, through wear and tear, years after year, decades after decade, the natural rocks are fragmented, are becoming a powdery mass or some mixed mass like this. And they are stored where it is obtained. They are stored in some reservoirs, sand dunes, deserts, in the river beds, right? And depending on the type of the mother rock, whether it is a quartz rock, whether it is a silica, whether it is some other type of rocks, accordingly, the sand particles will have different properties. So it depends on the basic or mother rock. So that is the sand actually. What is sand? That is a sand, fragmented piece of rock. How it is accomplished, that I have mentioned, and where it is obtained, that also has been mentioned. So rock particles, that is sand, is mixed with, you just observe here, mixed with some binder. Now what is binder? Binder means which will bind all the ingredients together, like say adhesive. Adhesive is a synthetic binder. Likewise, we have various other synthetic binders. For good quality jobs, we use synthetic binders. But sand is already mixed with a constituent known as clay. Clay is naturally available binder. And what is clay then? Clay is again further the sand particles. When sand particles go further refinement through filtration, and when it is mixed with, say, waste leaves, waste woods, after so many conservations, right? It is a muddy like appearance. It is having a muddy like appearance. So that is a clay. So clay is also a sort of sand, more processed. So that is having, clay is having some sort of binding ability, some adhesive quality. So sand, natural sand is already mixed with some clay as well as some water. Okay. So this is, if I collect sand from nature, then sand is already mixed with some naturally available clay as well as some quantity of water. So that is natural sand. But for good quality jobs or industries, artificial sands are used. That is, pure sand is mixed with some synthetic binder. It is free of water, so water or moisture is to be added in adequate amount. It is also mixed with some additives. What is known as additives means some qualities may have to be enhanced. So what are the qualities that again will be discussed? But you, for the time being, you take it that some qualities like, say, strength or hardness, refractoriness, some qualities may have to be enhanced. So some additional element, chemicals or inorganic organic substances may have to be added. So those are known as additives. So when all these are mixed, that is the molding material. And when sand is the major ingredient, that is known as sand casting. When sand is not used, some other name will come. Okay. So all these, so these are the basic requirements. That is, we must have a pattern, we must have sand as a molding. If it is sand casting, we must have sand as a molding material, and we must have a container to transport or to pour molten metal from the furnace shop to the foundry shop. So container of molten metal. And then again, there are various types of foundry practice, foundry operation. So here in the figure, what we are observing, this is a case of cope and drag pattern, cope and drag type of system. The top upper flask is known as cope box or cope flask or cope half. And this bottom part is known as bottom half or drag flask, drag box. Okay. So cope and drag type of pattern. This is one, but there are many more. In the shop floor, in the workshop video, what we had observed, those who had observed, they might be appreciating that the concept was the same, cope and drag, but there was no drag hub in that video. Only cope box or cope hub was utilized. A cast iron box, open, hollow. This is hollow also, obviously. Made up of mainly cast iron, hollow box. But in that workshop video, though it was termed as scope and drag type of system, but there was no drag hub. But the floor of the shop floor that served the purpose of drag. Right. And cope box was placed on that drag hub, means floor itself served as the drag hub.
Yes, sir.
But say if I am accomplishing the job standing on a bench molding, what is known as bench molding in the industries, that is very common for smaller jobs. Floor molding, one is floor molding, that was followed in our workshop video, or in our workshop we used to follow floor molding technique, where floor itself serves the purpose of drag hub. And in the workshop or in various industries also, we may have bench molding. Bench molding means standing on a bench or placing all the systems on a bench. So in that case, we must, because there is no floor covered with molding sand, molding material like our workshop. So on that wooden bench, say, or a steel bench, we may place one box, empty box. We may fill this box by molding material. So that is a drag hub. And the half of the pattern, if it is a symmetric one, then half portion here will be inserted inside this drag hub. And the upper part okay, so this looks like this. So insert the half portion inside this drag hub and fill it with sand. Then ram properly. Ram means apply pressure around this flux as well as around this pattern to adhere the molding material, that is sand, thoroughly. And how it is packed or how the pressure is applied, using a tool known as rammer. Okay. Apply pressure with a rammer. So this end is known as butt end. But this may not look like a say a rectangular plate like this, but in our workshop we have a blunt tool like this, where this is the butt end and there is a handle on the opposite to hold the tool. So this is the butt end and this is the handle. So grip the handle and apply pressure with the blunt edge. Okay. Pack the material with sand, pack the pattern with sand, half portion, and half portion, then you place the cope up here and then fill this blank portion with again molding material, again pack properly. And again, as you are inserting this scope up and drag up, and now the inside the wooden pattern is trapped. So what is my purview? What is my objective? Is to prepare a cavity, but I am placing a pattern. So next I should remove this pattern to get the cavity. So what is the next step here? Half portion is inserted. You place the job like this. It looks like this. So this is the first. First of all, mix the sand. Then you place the job here. Pattern is placed into the mold, right? And this is the sand. Pack the sand in the bottom flask or drag, compact using rammer, and then insert the cope up here through these slots. Why? Again, I shall discuss. All these are important. You should align these slots, not arbitrarily. Okay. So collide or align the top and bottom half. Again, fill this blank portion with molding material, pack properly. And here also a tube, not tube, it is known as a screw pin. So later on we shall discuss. What I told you that there are so many terms to be mentioned simultaneously, but for the time being you may not understand all of them. That's why I am not mentioning, I am trying to avoid as far as possible. Tube, it is not a tube, it is known as a screw pin. But you insert a pin, why? Again, that will be discussed separately. Not a single, another pin is to be inserted. There should be two. In the figure, there is only one, but there should be two. So after third step, you fill the, you place the flask, again fill this cavity with molding material, ram. What I am telling, that pattern is still inside. Pattern is still inside. But I want a cavity, hollow portion. So how that is possible? So after packing properly, then again you just observe, lift, take out. And lifting this cope, which is now, previously it was empty, blank, white. Now it is filled with molding material, packed. This is also filled with molding material. Now, somehow, how that will be again discussed later on, using lifter and mallet. So you take out, remove the pattern. So pattern has been removed here. So as soon as the pattern is removed, what I am getting? A hollow portion. A hollow portion, right? Conforming the shape of this thing. Okay, now I am a hollow portion. And as this is taken out, so already you need not remove it from the upper portion, or upper portion is already having a recess like this. You understand? You follow this thing?
Yes, sir. Yes, sir.
So when again, after removing this pattern, again you place the cope up. Now there is a cavity inside. Previously there was a pattern inside, but now as I have removed, now there is a cavity inside, a cavity conforming the shape of the pattern. Now again remove this screw pin also. Remove this screw pin also. As soon as this is removed, now there is a hole, downward hole. Why it is needed? To pour molten metal. This is known as pouring basin. So now molten metal is poured from this hole. It is coming down through this passage and entering into the cavity. And the total cavity is now filled by molten metal. And then allow it to solidify. After some time, you again remove this cope up. Now this is furnace, melting of metal is going on, and it is transported by this pot. Molten metal is poured. So allow, wait, this is say watch, the replica of a watch. So allow some days, and depending on your metal, what is the metal? Wait for the metal to cool. Maybe some few minutes to some few days, depending on the size and type of metal. Size, if size is very large, then obviously more time will be required to solidify, or some materials may lose heat very slowly, etc. So depending on that, allow some time. So after allowing, again you open. So now the part is solidified. This is made up of metal. Okay. And now what you just observe here, another, this was not here, but I am getting a part with some protruded portion here. Where from it comes? From the passage, that is from this pin. So molten metal has been poured here. So when metal remains inside after pouring, so that will also be solidified. So that is appearing like this. So now the task cleaning or finishing. So what we told here, okay, casting, then cleaning and finishing. So here comes the question of finishing, because I don't want this protruded portion. I require this shape. But here it appears like this. So I must break this or clean this, or the surface roughness may be very high, so I will have to polish. So cleaning. So cleaning sand is a very important. So cleaning, next step. After 9, 10 is mold forms are reused. Then sand is broken up for the next operation. So this is all about. Now why this? Why I would like to mention why these slots, these are known as guide pins or dwell pins. Why this is to be aligned? Because I am first I am placing it down, again I am taking it out, again I am placing it down. So number of times I am opening and again replacing the cover. So in doing so, there may be a mismatch in the parting line, parting plane. So if there is a mismatch, then the resultant part may be a defective one. What is the type of defect? Again, I told you that there are so many terms I will have to mention, but it needs discussion. You may not understand. So later on you will understand. So read, again read. In this way, you will have to prepare. So the defect, what may happen is known as the shift. The parting line will be shifted. That is, the resultant part may look like, not necessarily. If it is not aligned properly, then obviously the resultant part may look like so same thing, but is shifted. This should be aligned to this, but instead the upper part is shifted somewhere here. Similarly, this also. So this is a defective product and it will have to be rejected. That's why the guiding or dwell pin, guide pins, marking different areas are all important. Okay, to ensure the proper alignment. So this is the process of your preparation of the cavity. This is the process of preparation of the cavity. Now, so what are the 1 minute, the pattern I shall discuss later on, but what is the molding material? We are talking about sand. So again, there is another figure, green sand molding. Why green sand? Again, I shall tell you, but this is the overall picture as we have discussed. As we have discussed in our previous slides, that is using cope and drag. This is another picture. That is, this is the cope hub, this is the drag hub, and pattern is placed here. This is drag hub, you observe here. Pattern is placed here. There are some guide pins. And this is filled with molding material, that is sand, say. It is packed properly. Okay. And then it is converted in upside down manner. It is inverted in upside down manner. So now this pattern is going into the top. So this is the figure, okay? And then what I was telling, that two pins, screw pins are placed here. Something is written, some riser, screw, etc. Why? Again, I shall not discuss today. But this is for, say, pouring of molten metal. Another is for something else. So that will be discussed separately. So again, this cope hub is now placed and some screw pins are fitted, and it is filled with molding materials and packed properly. And then the pins have been taken out. So now it looks like this cavity. And again, from this drag hub, again, the pattern is taken out, leaving behind a cavity. Okay. Then, again, in this cavity, you just observe, this is very interesting. There is a cavity, right? Now, here in this figure, this is figure, say, F. And this is figure EFG. So after this is sequential. So after obtaining this cavity, here you just observe a sand mass is placed, known as sand core. Now again, the cope hub is fitted here. Okay. And the molten metal is poured here. Now, molten metal is entering through this down gate, and these are the gates through which molten metal is entering. Now tell me, if molten metal is entered here, then it will fill up the total cavity, but as there is a sand obstruction, okay, so molten metal will not be able to fill this gap, right? But other hollow portions will be fulfilled by the molten metal. So after solidification, we may get a part where some portion is hollow, remains hollow. So this is achieved by a object known as core. So cores are used. Core. So cores are used where the entry of molten metal is not desired. Entry of molten metal is to be restricted. So that is achieved by the application of cores. Okay, so again we shall discuss many more about cores. And you just observe here some some cavities are prepared, small capillary cavities, using a small tool known as vent rod or vent wire. Vent rod or vent wire. Again, we shall discuss with basic hand tools required in case of molding. So this vent wire or vent rod is used to perforate the cope hub in different portions several times. These are capillary passages required for the escape, because when molten metal will be poured, molten metal contains various dissolved gases. Metal, it's a metal mixture of various alloying elements. So all these may form various gases. Not only that, atmospheric air, because because the molten metal is prepared in furnace section, which is located in some remote area, not remote, in some some other corner of the workshop, and from that area the metal have to be transported by ladle to the foundry. So during such transportation, atmospheric air may be entrapped. So metal may contain various dissolved gases, and atmospheric air will also be entrapped. And not only that, this molding material, that is sand, molding sand itself contains moisture or water as one of the ingredients. So when molten metal will have very high temperature, you imagine, say, if it is steel, molten steel, very high temperature, 1400 degrees centigrade. And as soon as this moisture or this water ingredient of the sand molding material gets that heat, readily some evaporation of the moisture will take place. So all these will increase the entrapped air or gases inside the molten metal. And if these gases are entrapped, then later on, after solidification, so many airborne defects will be generated. So what are the defects? That again will be discussed separately, casting defects. But majority of the defects are due to these entrapped gases or bubbles or airs. Many more. So task is to try or to minimize the quantity of entrapped gas. We can't completely remove the entrapped gases, but to minimize. Molding sand itself is having a property known as porosity. Next day again I am telling that so many terms I will have to utter simultaneously, which needs to be explained in detail. But porosity is the openness or voidness. When because sand particles, I have already mentioned, sand particles are having different shapes and geometries. Shapes, geometries, sizes. Some of them are completely circular, some of them are pentagonal, some of them are looking like this, some of them are triangular. So many. So and sizes are also different, from very small particles to some medium coarse particles to very large particles. And when all they are amalgamated, collected, then in between the particles there will be some openness or void spaces. Do you follow? These void spaces or open spaces are the concept of porosity. If the particles are very powdery mass, like talcum powder, then obviously the porosity will be very, very less. A compact structure will be obtained. But if this sand particle is completely compacted mass, then what will happen? The passages are very small. The entrapped gases will have very little room to be escaped. On the contrary, if I use some larger particles, then obviously the recess, these void spaces are very large and the gases can easily escape. But in that case, the surface finish of the job will be rough, very, very rough. So both these are having problems as well as advantages. So I must have to balance. The balance is needed. So whatever sand size we are using, whatever may be the sand size, porosity. So sand obviously will have some porosity because it is a mixed mass. I have mentioned it is not a compact, completely powdery substance. not a completely coarser substance, coarsest substance, it is a mixed. So it must have some void space openings, porosity. But also, artificially, I am also providing some passages. So this is the function of this ventoire or venting. Okay. And all the times it must have to be aligned, this using guide pin or dowel pins. So this is the setup of green sand mold. Now you may ask why it is called green sand. So next class we shall discuss in detail about the various sand materials, because first we are starting with sand materials because that is a very basic, common, generally followed, but there are other casting techniques we shall discuss. So sand, this is the technique, that is the practical aspect of this part. In that meantime, you must go through the workshop video to understand in further detail. So next class we shall discuss theoretically what are the various types of sands, what are their properties, etc. etc. Any question up to today's discussion, or we shall quit today? And regarding books, you know what are the books? You know what are the books? Okay. Chat box, you follow the chat box.
Yes, you can write over there.
Now, Workshop Technology by A.J. Chapman, all 3 volumes. This is not necessarily for this foundry. This includes all the manufacturing aspects. And not only for this second year or first year, from very first year for mechanical, from very first year to fourth year, even after that also, A.J. Chapman is a very essential book. So you may procure one, all the 3 volumes when you are going through A.J. Chapman. Not necessarily the first volume includes the basic and other things are included in higher volumes. All 3 volumes are required, right? And if you follow Workshop Technology, the name of the books are almost same. So that's why I'm not writing the names of the books. I am writing the names of the author by very common, but this is not a good book, Hajra, for particularly for mechanical engineer. But if you go through this Ajay Chaudhuri, then volume 1 is sufficient for manufacturing process. Volume 2 is meant for machine tools. But Ajay Chaudhuri, volume 1, you may go through, but preferably you should follow other good books also for mechanical engineers. So Workshop Technology by Chapman, Hajra Chaudhuri, then Workshop Technology by spelling may be something wrong. Amstead Oswald Benjamin, very good book. Workshop Technology by again the spelling of Smith may be going wrong. You check the spelling of Smith. Kalpakjian and Smith, very good book. So Amstead Oswald Benjamin, Kalpakjian Smith, they are very good books. Okay. Workshop Technology by Kalpakjian and Smith. Spelling, you check the spelling, this is wrong. And Amstead Oswald Benjamin, this is also good book. Then your Workshop Technology by your Roy Lindbergh. Workshop Technology by Roy Lindbergh. these are good books. Oh, fine. Mechanical Metrology by George Dieter. Okay. So in this way, there are so many other books also. And time to time, not now, regarding sandcasting, I shall also mention some 2, 3 names. You may also, because people used to read this book also. I don't know whether this is very good workshop technology by or manufacturing technology by P.N. Rao. I am not very much, I mean, thorough about this book. I don't know, but people used to. Another is Workshop Technology by Ghosh and Ghosh Mollik is also good. So in this way, there are various good books. So if you go through books, you must go through at least some good books. What is my? Reference means you should read Amstead Oswald, Benjamin, Kalpak, and Smith. Dieter George is very difficult, but if you are interested, Lindbergh is also good, right? PPT I may send, but that may not help you in that way. But okay, I shall send you, but not right now. After some time, when so many things will be discussed, then and only then. Okay. But don't
Yes, sir.
depend on that PPT, because there are so many things in between the lines, right? That's why you should read books. You should go through the workshop videos, and that is the right way.
Yes, yes, sir. This PPT will be just for our reference, sir. We'll be
Okay,
definitely going
okay.
through the books.
Yes, it's all right. But today, right now, I am observing there are 45. Obviously, including my presentation myself. So most likely there are some 42, 3 students. But to start with, there were some 50, 51 like that. So in that due course of time, Saumodi Bhattacharya has left the meeting right now. Shantanu Mondol has also
No,
left the
sir, I
meeting.
have joined again.
Okay, but what is my point? From the next day, because it is rather it is time consuming, it is rather difficult. Some of you are joining. My request is to join in right at the beginning and continue watching all this, because the communication mode is very difficult mode in by this time in this time. This is not a good I mean uh, way medium. So that's why you try to attend and follow the things. There are various constraints, like sometime I am not in a position to understand whether connections are all right or not. It happens that I am talking for 10-15 minutes, but after that the students are telling, okay, you had missed. So that is same to you also. So both way. That's why I try to attend as far as possible. And the CR, I don't know, there are 3 CRs. So who will take care of this class? I don't know that. Who is the main CR? Vishal.
Yes.
Yes.
Okay, so Vishal Roy, along with other CRs, discussing with other CRs, that is in consultation with other CRs or students, all the
Yes.
students.
Yes.
You keep that, you send, because what another problem I faced yesterday. I sent one group mail, but perhaps you had not received from my end. When I mailed through your group mail, some message came that this group mail is invalid or something. I informed your CR Vishal Roy, and he
Yes. Yes,
then
sir.
circulated the link for today's class. But
Yes,
I
sir.
tried to communicate to all of you, not to the CR only.
Yes, sir. Yes,
Right,
sir.
but unfortunately that failed. So that's why CR take that responsibility. You create a group mail, legible group mail, and create a link also, class link, send it me also. Regularly I shall join in that. I shall join, not I shall give you the link.
Yes, sir. I can understand.
So you used to conduct and also keep the record of the attendance.
Yes, sir.
Will it be feasible for you to keep the track record and send it to
Yes,
me
sir.
immediately after
Possible.
the end day's class?
Yes, sir.
If is there any problem, or I shall do the needful?
Yes, sir. You can manage. No issue.
Okay. You send me the information, that is how many of you are attending, and so in the next day, that is in the next Saturday, so I shall